Types of valves. Let's see here. The first one is a ball valve. They're calling it a ball cock, but we just refer to it as a ball valve. Those are typically quarter turns. Um, when the eye is in line with the water pipes, the water's going to flow. Those are adjustable, so you can go ahead and you know feather the water flow that comes in there. Gate valves, or let's back up to gate valves. Yeah, those keep it there all the way on the right hand side. Those are really designed to be fully open or fully closed. I got nothing that I can back that up with, and I've done some researches, to find out why this is, and I have no history or experience. But from what I'm getting or gathering, whenever you slow that valve down, you ruin that gate that's in there, and once it gets wedged or twisted in some which way, and that damages it. But again, I have absolutely no proof to that whatsoever. Both the ball valves and the gate valves, they pretty much can go any direction. All right, it doesn't matter which way the water is flowing on those; it's not going to matter. The globe valve, however, it does matter. All right, and even though they say that you can adjust the flow of water on these things, um, as far as I'm concerned, they're probably the most problematic valve you can ever put in a house. And what's kind of weird is like every water spigot that's a frost-free spigot, those are a variation of a globe valve like this. So where that black piece is, that's more of a rubber washer that's flexible and bendable when it comes in here. And as I open it up, now this water is supposed to be flowing from left to right as we're looking at these diagrams. And as I open that up, the water is going to go up and keep pushing that valve upwards, and then it would work just fine. What happens if somebody puts this in backwards, and there will be an arrow on the outside of these things, which does show the water flow, which way it's supposed to go in there. So we can check for that. But now if the water is going the other direction, and I keep forgetting that I'm reversed on the camera, so the water is going the other direction, if that valve isn't open all the way, then that water is going to keep hitting that valve, and we're going to end up getting water hammers. And again, it's going to sound like machine gun fire. You're just going to hear boom, 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 boom. And what it is that valve just constantly opening and closing as the water pressure keeps changing and going back and forth. So if it's in the wrong way, you got to get that thing all the way open. I think you're going to find that when you open up sprinklers on the outside, and I'm talking about the valve itself, they're switching those over to be quarter turn valves now for all the newer ones. But in the old ones, we had a whole bunch of turns coming on them. And as you open them up, you start getting that water hammer or that vibrating. And that'll continue until you open it up all the way. I'd like you to know the term cross connection. This actually used to be one of our mandated defects that we had to call out in the state of Illinois on our SOP. And I think it's a big deal. All right. I know that the chances of something happening are minute, but the cures are actually inexpensive and simple that we can do it. So the term cross connection means that there's a possibility that our drinking water, or let me back up, any wastewater can be siphoned into our drinking water. So if we look at the left-hand side, we see a garden hose and a puddle of water. Once that water leaves that spigot and enters that garden hose, it's wastewater at that point in time. All right. We don't want that water ever being able to come back into our potable drinking system and go elsewhere where I could drink this, through a cup of coffee or something else. All right. We don't know what's in that lawn. It could be pesticides. It could be fertilizer. It could be a whole bunch of other stuff that's in there. We don't want to draw that back into our drinking water and get somebody sick. So what we can do, and on the right-hand side, they're showing the spigot below the flood rim in that tub. So as I fill the tub, it's going to be filled up with water. Now, if those valves are open, and let's say, again, the fire department comes by and the driver of the fire engine wasn't paying much attention, or maybe somebody else hooked up to it as well, and they can actually create a negative pressure in those water lines. All right, it is possible for that to happen. In fact, it happened to me a couple of times. I'm pulling off of one hydrant and then another engine hooked up on a different hydrant, and he basically stole my water. So then as I'm trying to draw water out of it, I'm going negative. Anybody that had water spigots open in their houses, I would actually be taking all the water from their houses and bringing it into the water system there. So it would be siphoning. In this case right here where that tub is, if that was happening and that valve was open, I would actually suck all that soapy water and dirty bath water. I would suck that back into that pipe where somebody could use it again at another time. So, how do we prevent cross connections? The best prevention is going to be with an air gap. All right, so some sort of a opening. If I fill up that funnel with water and I just keep filling it up, that funnel is going to overflow. All right, there's no way the water is going to get high enough so that that pipe that's above it is going to be in the water, and then I'll be able to siphon from there. So any sort of an air gap will always be our best defense against any sort of cross connections or siphoning of our water system coming in there. If we don't have that ability, so here we're showing our tub again, we have that cross connection on the bottom. You know, they do have anti-siphon devices that you can install in the water system itself. All right, so it's not necessarily the end of the world. So when everything's running and everything's pressurized, that cap on the right picture is pushed upwards there, and that keeps the water from escaping or leaving. However, if I create a negative pressure inside the pipe, so now everything's going backwards in that pipe, that seals it up, opens it up, and allows air to enter. And this way, air is going to enter the pipe, and we're not going to have to worry about any of that wastewater going into our drinking water. The same thing can happen with those garden hoses. These little anti-siphon devices, they I don't know, they're like $5 or $10. So even if I have an old faucet that doesn't have an anti-siphon, you know, for a lousy $5 or $10 item, and all they have to do is screw that on the bottom of it, we take away even the most remote chance that we'll be able to siphon any of this water back into our system. All right. So I like to encourage that as well. These are the air gaps that are found in dishwashers and stuff. Nobody ever does this. You know, I've seen pictures of them. I think I was in one house where I did actually see somebody install it this way. And it was with the Formica countertop, and sure enough, the countertop was damaged from water right around this thing. So the water comes out of those dishwashers so damn fast that, you know, it just, sometimes it overflows these things. That's all there is to it. So around here, it's just been a common practice not to do it. But nonetheless, I want you to be able to recognize it if you see it. You know, so the dishwasher goes up, it comes over the top. We have the air gap, and then it goes back into the drain that goes into the waistline. Typically around here, we're going to take our dishwasher and we're going to go and mount it or secure it to the top of the underside of the countertop. It's what we call a high loop. That's the common practice, not putting in one of these air gaps. I'm not saying there's anything wrong with it. All right. I want you to know the term dielectric union. Anytime we have dissimilar metals that are touching themselves, and dissimilar I mean aluminum, steel, copper, tin. Those are pretty much most of the metals that we deal with that are going to be an issue. None of those can touch each other. All right, there might be more, but none of those can touch each other. Now, there's also brass that gets used a lot in plumbing system. Brass is the only metal that could touch any one of those. So brass is a natural dielectric union. So if I have a galvanized pipe, galvanized steel, and I guess iron should be added to that list too. If I had a galvanized steel pipe and then I put a brass fitting on it, and after the brass fitting I go to a copper pipe coming in there, that's acceptable. That's the same thing as having a dielectric union. But if we look at this and we look at the breakdown of everything, we actually have a piece of plastic that's going to separate the steel and the copper. So those two pieces of metal will never touch each other. And the plastic is actually going to be our washer to get us a nice tight, watertight seal. These fail. All right, I don't know what much more to say. If you find corrosion around this thing, that means that it did fail. And it does need to be switched out or changed at that point in time. Corrosion equals leakage. Anything that has ever corroded has leaked and will most likely leak again. It's not if, it's when. And we can't predict when it's going to leak again. Same thing with them touching on the outside. All right, so if I have a copper pipe being held up with a steel nail or resting on a ductwork, steel ductwork that comes in there, just by touching those two metals like that causes the electrolysis to happen. And the stronger of the two metals is the one that's going to start being corroded. Usually it ends up being, on this case, I think it ends up being the steel, or no, it's the copper is where it comes in there. But it doesn't matter. We're looking for all the corrosion, changing of colors and so forth when it happens, and we want to avoid any sort of leakage. Now, the cure of this, again, is simple, all right? I don't care what it is, cardboard, newspaper, anything that I can get a separation in between the two metals. Typically, somebody will put electrical tape on there. That works just fine. As long as they're not rubbing and we're going to deteriorate that electrical tape, that'll be just fantastic. But I've seen people put pieces of cardboard in there, anything just to keep the two metals from touching. And as long as they don't touch, then the electrolysis won't happen. Water hammers. So basically when water's in motion and then I hit the valve and I turn it off, that moving water is energy, all right? And it's kind of like if you take a garden hose and spray it at a wall, you can see that it goes off in all different directions. And when it goes off in all different directions, that's the force where it's changing. And that's actually pretty strong water. Usually we can even finite that and make it even tighter streams and build up power washers where it comes to it. So water in action and then channeling that energy or making it stop or making it smaller has a tremendous amount of force to it. All right, and we call that water hammering. So in this situation, what they're doing, they got a valve, we turn it on, turn it off. Every time that water flows and then we instantly stop it, that pressure is going to be like hitting a brick wall. So what we do is we have air, or in this case, we have a piston, a seal in a chamber. Since air is compressible and water is not, as long as I have a chamber of air, then that's going to go ahead and compression is going to cushion that stop. And that'll prevent the water hammering. If you turn valves on and off and all of a sudden you hear some rattling, chances are if we have a mechanical device like this, it's broken. If we have an air device, such as the one on the right, those get filled up with water. So the air does get absorbed into the water over time. It's normal. It does happen. Sometimes we'll see a whole house chamber as well. Those get damaged, and again, the water fills, or the air gets absorbed into water, and then the water level keeps rising when it gets up in there. Simple solution to those two is you just drain your plumbing system. So shut off your supply lines coming in, or your service line coming in, empty out all your supply lines, open up all the valves so everything can escape, and then you go ahead and close all the valves, turn your service line back on again. And what we do is now we added that air back into those air chambers, and we'll have that cushion come back for us. The mechanical ones, if those failed, the only solution that I'm aware of is replacement. I don't know if there's any repair to those. Now the whole house one on the far left, that's a little bit different. Sometimes those have an air hose at the top of them, so you can add air pressure to it.